agenda around here someplace. Maybe not. So with this thing in full slide mode, let's see if we can click it. BMWG. Okay. So there's a magic sequence of buttons we have to press here, right? It's this one, and then we have to see whether this works. Oh yeah. Okay, that button there. Got it. Okay. Yep, seems to be working. Awesome. Thank you very much.
Thank you, ma'am.
Let me do that pasting in real quick here. So we got this. We got meeting materials. Well, that's waiting to come up. I can pick up all of this. See. Okay. Oh, wait a minute, that's not right. I want the agenda. HTML. Bingo. So all that red stuff is, when you get to the Etherpad, all that red stuff is going to be the agenda, and we can get this. I don't think we can actually delete stuff, can we? Oh, we can. If you own it, you can delete it. Okay. So, and I'll ask somebody to screen scrape the Etherpad occasionally, put it in a text file, because things go wrong with Etherpad. And that's an unfortunate reality of our business. All righty. So it's 10:01. I think we can get going. You about ready, Sarah?
Yes.
Okay. So Sarah's going to cover Jabber today. I guess we've got a collective of a few people who are taking meeting notes and contributing to the Etherpad. That would be great. Type in a few, mostly the action items that come up. I mean, that's the kind of thing that's interesting. Also, the questions that are raised. These are the key points that we want to capture and preserve for posterity. So I'm Al Morton, and this is Sarah Banks. Good morning.
Good morning, Al.
So we're the co-chairs of Benchmarking Methodology Working Group. We're, in general, asking folks to move close to the front, but everybody's sat down now. Nobody's going to move. So who are first-time attendees here at Benchmarking Methodology Working Group? Oh, great. A few hands. And so welcome to you all. If you guys are testers, if you've worked in the lab, if you have an interest in what other people are testing and some of the technologies that are on our agenda today, and this is the place for you. And you'll find this a very easy working group to join. You can read some drafts and provide some comments. You can read some of our fundamental RFCs, and you'll learn very quickly what it's like to prepare an RFC in this area, starting out with an internet draft and so forth. We have a, on our webpage, we have also a supplementary page that kind of gives a little guidance along these lines. So welcome. All right, use the clicker, Al. So here's the note well. So we got to go through this a little bit because this is exactly the first meeting of the week. Usually we sort of hand wave and say, have you seen this already? But we can't today. So we work as individuals and we try to be nice to each other. That's our personal note well to you. Beyond that, basically everything you say at the microphone, every mail you send to our list, and sort of every other kind of public conversation here is a kind of considered a contribution to the IETF. You have to be aware of whether that conversation on your part is covered by IPR. You need to disclose that in a prompt fashion. And so that's basically what we're asking of folks today. If you've got something you're presenting for the first time or a new time and is covered by IPR, please let everybody know. Thank you. There's links there to sort out all the details. And if you have any questions, Sarah and I are not lawyers, but we can at least try to answer them. So here's our agenda, and you can see right from the top, it's really full. So we've got the, we'll talk about the benchmarking for EVPN and PBB EVPN status. We'll go into our charter and milestones and the general working group status altogether. Then we've got the, we actually don't have a presentation for number 3. I don't think Karsten has joined us, but I can quickly give a status there. And then we have one other working group documents, the updates to the back-to-back frame benchmark, OPNFV and VSPERF testing. So that's that's a topic I have to cover as a participant. I'll try to remind you that I'm changing hats when I do that. And we actually have quite a good number of good comments on the list, so that should be a good discussion. So then we have the continuing proposals. You see the large number of them there. So we're going to have to restrain the time that we spent on this, and also a lot of remote presenters. You can see that indicated, and then we return to the EVPN topic at the end, where we have a couple of drafts and one at the end here where we had some more list discussion. One new proposal where we have a brief presentation, 5G transport network benchmarking. Luis Contreras. Luis, are you here? Luis? No Luis yet. Okay. Well, and an FYI from Vladimir Vasilev. Vladimir is present, but he didn't plan to present yet. And but the draft is available, so folks can read that, and by the time Vladimir does present, it will be better informed. He's trying to sort of understand how the working group works, and I think that's a great way to go. Also, in general, when you come here and make a proposal, join the group, read somebody else's draft, help them along, they'll help you along. It's a give and take kind of thing here. Much appreciated. Any bashes to the agenda? See no requests for the floor, nobody at the mic. So as I said, we've got the Jabber and the IPR covered. The blue sheets are going around. Everybody please sign the blue sheets. Where is the blue sheet at the moment? Right up front here. So let's keep that circulating, make sure everybody's signed it. And how many names we got on there right now, sir? 12? All right, there's a lot more than 12 people in the room. So let's get the rest of the folks signed up on that. Otherwise, we'll be meeting in a broom closet next time. We don't want that. Okay, so I think that's it for the agenda. Everybody found the Jabber page, or not? I'm not sorry, Jabber. Etherpad page where you can type in some notes for us, help us out there. That would be great. Okay. So here's the status. In the interim, we've adopted the back-to-back frame benchmarking. It's an update for the particular section in one of our fundamental RFCs, RFC 2544. And this is where we try to determine the size of a buffer that the device under test has. And that turns out to be pretty important. We'll talk about the details later. We've got all these proposals with drafts following up on all of them. And there we go. So we've got this is the reason we have a full agenda. We've kind of blown through all our milestones. We have to fix that. It's real easy to update dates here and by a year, I think, roughly. And I mean, we might actually make it if we do August 2019 for next gen firewall. That seems makeable. They've got a good draft and stuff I've read.
Well, they're all 2018, so technically speaking.
No, we're going to update update them all to 2019.
I see.
And then we'll make it. You're allowed to update. You're allowed to do some updates. Yeah. When we put this in, people went, "Oh, really? August 2018?"
We thought it was aggressive.
We thought it was aggressive too. And I think one of the problems is one of the authors has left his position. Mm-hmm. But in any case, there's good work that was done there, and I think we can get that going. Enough on that. So keep looking for the blue sheets, folks who are arriving a few minutes in. And so here's where we stand. No new RFCs, no charter update. We got this is the supplementary page for new folks joining the group. That's where you go to find out, all the details of things that I just said very quickly.
Oh, can you go back a second?
Yeah.
So especially for the new folks coming in, especially on top of which we have an awful lot of virtualization work going on. If there's information you guys want to share, tools, implementations you've seen of things that we're adding, can you send me the links and I'll make sure that we're updating the page so that stuff is reflected in a central repository, because sometimes I find you actually, Al, send out emails periodically reminding us of it, and it might be good to list that on the page.
That's right. That's right. In fact, Vladimir and I had a conversation about a test traffic generator prototype during the Hackfest briefly. So that interesting stuff. Yeah. Okay. Thanks for the augment there, Sarah.
Sure.
All right. So when you write an internet draft here, we are laboratory only. That's our charter. So we put this nice paragraph into the, some parts into the intro, some parts in the security considerations section. And when the security people read it, they go, oh, okay, it's all right now. And so that's very important to let them know when they review the draft that we're lab only and we're not doing this stuff on the live network. And I haven't really updated this to include all the proposals, obviously, but here's the ones we have adopted recently. And they're all in green there. And so you can see the kinds of things we evaluate when we're looking at proposals for adoption. Okay. So that's the chair slides. I hope that wasn't too quick. Any questions? Seeing none, let's blast along. All right. Let's go back to the agenda here briefly. Oh, there we go. So now let's see. I guess we press escape. Nope. Maybe it's this. Yeah. All right. So then the first set of slides is here. And then this, and then this. So you can see that, so now I'm Al Morton, participant.
You want to stand in the box?
Oh yeah, I mentioned, and I wanted to quickly mention about, as chair, sorry, back to chair, in the chair. I wanted to quickly mention that we had some comments of an early security directorate review on the next generation firewall draft. The authors have heard them, sort of thinking about accommodating them, and I think that was a good cross area post. Took a while to get the comments, but Kathleen Moriarty did us a favor there and completed the review. So we thank you, Kathleen, and we'll thank you when we see you again in person. So, but no other updates there. What we're asking for next generation firewalls, people, please read this. So we're going to put this in last call, I think, soon. We'd like to see some more reviews on the list. It was generated by a large group of people, much larger than the author list. So that's the message. Next generation firewall, we're trying to finish that up. Please read it. Get ready for last call. Thank you. Okay. So when you're, so I'm going to take this out. If I'm strong enough.
There's no box.
Yeah, no, there's an X now. X marks the spot. Oh, okay. And I advanced the slides. Oh, there we go. Oh. Okay. So you can see that I'm kind of doing the very economical slide generation now, where I do this snip thing off the diff. Where I do this snip thing off the diff, and it's got all the information everybody wants, for a slide title. So this is our updates on back-to-back frame benchmarking. It's been a fundamental thing in 2544, and we got two sets of comments on the list. Masiek and Vratko. Masiek's comments were reflected in the 00 version, but Vratko's comments came right after I pushed that working group 00 version. So I didn't actually get to those until last night, and so we'll talk about those for a moment. Masiek asked for a couple of things, moving some text around. That's great, it's done. The goal is measuring ingress buffer size in front of the header processor. There's a picture here that I'll show you in a moment. As per the definition, so this works if there's no other buffering, add a paragraph dictating the setup. And I think we've got that, kind of got that covered, but we expanded on it a bit. So here's one of the changes. Likewise, this is in the scope. Likewise, the methods of RFC 8239, which basically focused on the egress buffer evaluation, should be used for test cases where the egress port buffer is the known point of overload. We're actually talking about some modifications for that, but that's a good thing. And then somehow in the working group 00 draft, this text was all deleted. And it actually gives our model, though. The model is that we've got a traffic generator and ingress to the DUT. There's a buffer in here, and then the header processing system. And so if the header processing system can't keep up with what you're sending in, this buffer grows. We try to do that with a back-to-back frame burst. The maximum burst we can send in without loss, it gives us an implied size of this buffer. So it's like just a very simple model of the DUT. Then we egress to the receiver and see if we've got zero loss. That's basically how this test works. So I actually added all this in version 5 of the document, and I figured out last night late what happened. I think I must have grabbed 04 when I did the 00 update, and that's how this got lost. So now it's back in for what it will be in 01. Okay. Okay. All right. And Masiek had a final list of comments which listed areas of noise to the measurement, which I basically captured here pretty much word for word. So we should, evaluate these, identify them, remove them if possible. I mean, this is the kind of thing that could, obviously we're using loss in this measurement to find out whether the buffer size has been reached, resources have been exceeded. So if we've got other sources of loss, we want to chase them away or understand them and test around them. So that's basically what this is all about. Okay. And then we're mentioning the importance of the ETSI NFV Test 009 specification, which specifies a search algorithm called binary search with loss verification. That's one of the ways that we can mitigate these cases where transient effects in a virtualized environment affect the device under test. And basically, it allows the binary search to search twice at every position, or multiple of times. But there's lots of factors there in terms of the trial duration and so forth to try to avoid the transients that you get that we used to be able to work around. We used to be able to say, okay, all the address learning's done and all the routing updates are done and now the device is stable. Yeah, in the virtualized world that we can't chase away all the interrupts. They're necessary for the health of the device. So we've got that in there as an explicit step in the measurement. And that's our corrected buffer time, which is really the main contribution of this draft. We're basically, just to go back, we're basically figuring out when we send a burst of packets, the header processing has handled some of the burst while we're sending them in. And so the size of the burst that we can send through loss-free is basically the sum of the size of the buffer aided by the number of packets that header processing has been able to pull out. And that's determined by the max throughput, RFC 2544 throughput of the device. So now in that recognition, we thought, this is the correction factor that we need now for the true buffer size calculation. And that's the main purpose of putting this draft together. So the broad comments from Veratco, I'm not going to be able to go through all of these in detail, but I plan to address them in version 1. One of the points here, he says, is that deployers wishing to predict the time for the buffer to fill using a real actual rate will be different from the back-to-back rate that we're pumping in. So he's saying we could add this calculation as well. it will basically come up to a longer buffer time because this is going to be your actual traffic. A question in my mind, though, is a tester going to know this at the time that they're running this benchmark test? And I'm kind of thinking this might be an appendix topic. It's a maybe for me. But basically, we're reporting the corrected time. That's supposed to be the most useful thing. And so the question to the working group is, do we add this calculation? Any comments there? People want to think about it, I guess. Maybe you have a comment.
Yeah, so as a participant, Sarah Banks, participant, I agree. Moving it to the appendix at best is where I would put it. I can't think of a real life example today in any network in which you know sustainably what your rate is. And even if you did, it changes every second of the day. So
bingo.
To have this here, I'm not sure that it helps. And it also sort of deviates from our typical mandate that in theory, we're trying to have apples to apples tests with repeatability, which you again wouldn't be able to do here.
Yeah, let's capture that this would not be a benchmark, and it's a piece of information that maybe we can tack on at the end. Let's see if there's any more support for it, and if not, we thank Vratko for his suggestion, but maybe we just don't put it in or any more than an appendix. Good, thank you, Sarah.
So Al?
Yes, Maciek, that sounds like you.
Yes, it does. Oh, great that you can hear me and even recognize me, not the machines I'm going through. Yeah, regarding Vratko comment, I'm also leaning to what you have suggested and Sarah supported. But on my end, I didn't have enough time to fully analyze the implications. So, tentative yes to what you have suggested. On the list. And the other very quick comment, thanks very much for taking into account my comments, and from what you have sent, I didn't apologize for not replying on the email, but what you have presented looks spot on. So thanks very much.
Thank you. Thank you. So stay with us, Maciek. Another Vratko suggestion was to change the names of things. So we've got, let's see here. So we've got the corrected buffer time and the implied buffer time as the current terms that we're measuring, and those, I mean, these are just names, but they made sense in the context of here's what we're doing in BMWG. So but Vratko suggests changing the names. Renaming the buffer times, the running buffer time and the suspended buffer time. Suspended being that the corrected buffer time is really all you have if suddenly the processor, the header processor stops. And so that's instead of implied or corrected. Any opinions on this? I'm kind of partial to the original ones, but I'm speaking as the author, and as a person who's working from kind of the original version of this specification. Maybe maybe we can incorporate those terms in the word definitions of these variables.
So Sarah Banks, again, as participant, I too share your opinion. I don't see an overwhelming reason to upend terminology we've had in 2544 forever. So one, we could take it to the list and see if other folks have opinions, or Vratko could expand and help me understand why he'd want to. But based on what I'm seeing here, I don't see a reason to support that. Yeah, no matter what, you'd have to define any term, and I think we've got definitions for the terms we used. So. It's a suggestion. We have to think about it some more. Thank you, Vratko. Let's see. I'm taking up a lot of time here. The Vratko had sort of an interesting conversation with. He examines the pluses and minuses here of using different parameters in the formula. This formula, instead of the maximum theoretical frame rate,
he thought maybe we should use the maximum frame rate without loss, or the maximum offered load. I've got it on the other slide here, which comes from RFC 2889. The frame rate at maximum offered load. So you put the maximum offered load in on the sort of the wired interfaces, and whatever comes out, that's this frame rate. That's what he was suggesting. You might want to characterize it there, but he also says not sure about how much attention other such quantities should get in the draft, and as throughput has the advantage of avoiding some frame sizes in the testing. So yeah, I think we need some contributions, experiments to show the value of this change. I think that's a good way forward. So we'll wait to see what happens there. And then device under test versus system under test. It's related to the Section 4 prerequisites. So there's sources of packet loss that are unrelated to consistent evaluation of the buffer size. They should be identified or mitigated. This material was just added. That was something Vratko was questioning. And do we have a separate document discussing the difference between testing the device under test and the system under test? Vratko thinks we should have such a document. Okay, but usually Vratko prefers testing the system under test, meaning no extra mitigations. But in this case, for the analysis of the three aforementioned scenarios to work correctly, we need to make reasonably sure the processor is not going to get suspended. So, I mean, he says also agree that the average of the binary search with loss verification is more realistic process for the rate estimate. So I think back-to-back benchmarking for a single DUT retains the needed simplicity here, at least for the scope of this draft. And if the working group has any other opinions about that, let us know. All right. So next steps, continue the discussion. We got some opens here, and address the remaining comments in 01. Try to target a working group last call at our next meeting in 106.
Al, can you go back to the slide that has the eliminating noise from Magic?
I think it's this one, isn't it?
No, a little more. No, yes.
Okay.
So as the person who will probably take this through working group last call, my ask to the working group is 2544 in my mind is a big deal. And if we're going to update an account for this, I think that having our eyeballs on it as a working group and our feedback collectively is really important on these things, because it matters in physical, and I think it could matter more in virtual. So I want to make sure if we're going to go ahead and update 2544 that we, not just a couple of us, but a good majority of us have and give out lots of input. Either yes, we agree, or no, we don't, and here's why. But my ask to you guys is, especially if we're going to try to working group last call in Singapore, is that we take a look at that. So please read this draft. Even if the only thing you focus on specifically are these specific things. I know Al wants us to focus on everything. We should.
Well, that's why I put it up here.
But if the only thing you have time for in your day is to go ahead and address these could be contentious. So getting everybody's eyeballs would be, I think, helpful to the community as a whole.
Yeah. Every
one of us tests. It's important. Please.
Thank you, Sarah. So, yeah, specifically, this is an update to Section 26.4 of RFC 2544. If you haven't read 2544, read it at least that far, yeah. and then jump into this draft, and you'll see some of the reasons why this is a good update. It's generally much larger expansion of the procedure that's there. So good. Thank you for your attention.
Sal. The agenda's not showing.
Oh, next one over, I think.
It says
Well, try that. Yeah, they're all in order, so you can just go down to the next one. And I think we've got that one up, actually. Ooh, was that a PowerPoint?
That's yours.
Oh,
No, it was PDF.
Well,
Yeah, good. So it sounds like you're ready to do. I don't. Oh, I see Vratko on the list there too. So which of you two is going to give the presentation here?
Radko.
Yes, me.
Maciek, okay. Well, Maciek, so we've got your first slide up. I hope you can see it. Please start and try to keep it to 10 minutes if you can. Thank you.
Actually, it's Radko presenting, but his audio is coming through very quiet.
Oh.
So Radko, you need to speak up.
Okay,
It's
can
yours.
you hear me? Okay.
Yes, now we can. Thank you.
So, hi everyone, I'm Radko, the person who commented on the previous draft, and I will be talking about so-called PLR search. It is new search algorithm, and let's go to the next slide. What gives us 2 here? So these are descriptions of what has changed from the previous draft. Mostly it's minor fixes. Most of this presentation is the same as we had the previous meeting. So let's go to the next slide. So here is the motivation, and so the main point of PLR search is that it is probabilistic search, probabilistic algorithm. So it is suitable for cases when the device under test or system under test is not consistent enough. Typical example is that you perform one trial measurement, you see 0 loss, but then you repeat the measurement and you see non-zero, maybe quite big loss. So this is problem for traditional deterministic algorithms, and PLR search is one class of algorithms that attempts to deal with this issue. Next slide, please. So the overview, the one important thing for PLR search is that it is not suitable for finding throughput as defined in RFC 2544, because that definition says that if it is throughput, you should see no loss. And this is very hard to prove when your system is not deterministic enough. So to make things a little easier for the algorithm, instead we defined so-called critical load, which is expected average of a loss ratio over multiple measurements. So typically you choose this parameter to be non-zero, but very small, let's say 10 to the minus 7, which means out of 10 million packets that you send, you accept only one on average be missing. So when you give this goal to the algorithm, it is easier for the algorithm to give both upper bounds and lower bounds so that you can pinpoint this critical load more and achieve better result. Next slide, please. So there are some differences, and one typical thing is that there are multiple probabilistic, let's call them models, that can model your device, and usually they range from very simple to more realistic, but very hard to implement. So PLR search is tending to, let's call it simple models, but still not broken enough so that the results are reliable. And we know that today neural networks and machine learning and the methods like that can give you very good information about your system, but they are not deterministic enough. That means that if you get slightly different data, the resulting suggestion can be different, and other people trying to get the same results will get different results. So it is useful but not stable enough. So that's why we are sticking to to proven statistical methods. Next slide, please. And this slide is new compared to the presentation the last meeting. There are some interesting observations. One observation is that sometimes the system under test shows behavior that depends on time. For example, the throughput is getting lower and lower because something is leaking or things like that. We are arguing that PLR search results are better even in this case compared to standard binary search. But yeah, of course, this is not a thing to be written in the draft. This is just side comments that we have done some measurement on it, and we are satisfied where we see the results. And yeah, there are some comments about how does it look like when the results are not that good, but that's easier to show to you. So next slide. Next slide, please. Yeah, these are the graphs for the fitting functions. There are two approximations that the algorithm uses to make decisions. The thing is that the algorithm chooses different offered loads, and most of the time the chosen offered load is not the final critical load that is searched for. So the algorithm has to make some reasoning about what does it mean when I measured too high or too low, how does it translate? So these fitting functions are used for that. You see graphs of them for a particular set of parameters that are there to show that in absolute values, the blue one looks that it is smaller, but when you look at the logarithmic values, you see that for very small overloads, actually the orange one gives smaller predictions. Next slide, please. And this is the example of what the results look like. Of course, this result is just a description, let's say debug output of the algorithm. The algorithm, in fact, only outputs two numbers, upper bound and lower bound. There will be the numbers from the far right. This is just to show you how the algorithm changes its evaluation over time. And when you see the y-axis, if you see the small numbers, this is very precise. So upper bound and lower bound is very close together, and this is how we realize that our system under test does not have exactly constant performance, but it is very slightly going down. So this is to show that PLR search, even if it is probabilistic, and then it can give you precise enough output if the system behaves well enough. Next slide, please. And this is, let's say, average case. The gray dots show the improved selection of offered load. This is the case when most of the results give you zero loss, but sometimes you give non-zero and quite a big loss. And you can see that the algorithm is trying to measure at the values that can give with some probability non-zero loss, even if the actual estimates are way below it, because we have found out that this way of choosing offered loads can give you better convergence. And this also shows you that the occasional big loss is seen to affect the estimates, and you can over time get worse estimate in so that upper bound and lower bound is far apart than it was previously. But it is what the algorithm should give you. It's just a consequence of very surprising data point appearing. So this is how most of the tests we are performing look like. Next slide, please. And this is the example where the algorithm is doing basically the same thing, but the upper and lower bound are not converging together very well. I believe this is still something that we can improve on. So the algorithm is not finished and written in stone, but this is the currently best way we have when once again the system behaves in a way that most of the results are zero loss, but when non-zero loss happens, it is quite large. Next slide, please. Okay, so here are the links. So there is FDIO open source project, and we are a sub-project called CSIT, and we are using this algorithm to show the behavior, but it is still, let's call it experimental. We are not running those tests for every scenario we have. We are still using deterministic tests for most of them, but when we are more confident about this PLR search, I believe we can switch back. Basically, we just need more data to confirm that PLR search one long run, let's say 30 minutes, gives stable enough results so that we can replace the currently used 10 runs of deterministic algorithm. Next slide, please. Okay, here are some implementation specifics, but looking at the time, there is no time to go into that. So next slide, please. Next slide, please. Okay, so this is the important thing. So aside of our part, implementing small improvements, we are, let's say, stuck at the adoption point of view because we didn't get, let's say, any reviews, and we know that the syntactic and terminology parts of our drafts are not very good. Maybe that's the reason that people do not want to review it. But anyway, to move forward, to receive adoption, we would like any ideas what we on our side should do, could do, so that it is easier for the working group as a whole to adapt and improve what is written in the draft.
Good, thank you, Vratko. Are there any comments in the room here? Has anybody, first off, has anybody read the draft? So just the chairs have looked at it. And one point, Vratko, is we had a special session on the data analysis last time. We gave each author a chance to present their data in detail and asked a lot of questions. There was a lot of good feedback from Karsten and me and other people in the room. I'm wondering if you're able to take action on any of that feedback.
Well, the most of the feedback was related to badly behaved system under test, and we were lucky enough that our system under test has improved. So we no longer have the source of badly behaved SUT. So most of the improvements were not used.
Okay.
But I think some of them still could be used. Just yeah, let's say.
So maybe in the future we can schedule a discussion that includes some more data that gets people's ideas flowing, and I mean the theory behind this seems fairly solid, but we need the reviews, like you said. So are there any volunteers to review the draft? I guess, okay, one, Tim from UNH will review the draft. That's good. Thank you, Tim. And we'll get you guys in touch. Thank you very much. All right. So with getting one reviewer here, Ratko, I think, and of course I'll take a look at it too. I think some of my comments on the MLR draft are probably applicable to your draft as well. So please try to take advantage of those in the next revision. And I think we'll close it there. Thank you very much.
Yes, thank you.
Okay, so we the chairs realized we jumped right over an important topic, which was item 1A on our agenda. It's the benchmarking methodology for EVPN and PBB EVPN. This is just a working group last call determination. That's what it sort of says on our agenda, and that's what we're going to do right now. Since Sarah kind of bound a draft that I'm working on in with this topic, it ended up now that she's got to make the call. So this is why we have co-chairs. Somebody can be working, somebody can be calling consensus.
So at the last IETF meeting and on list, I asked the authors to, we had several drafts for EVPN, and I asked the authors to sit down, talk together, and figure out whether or not these should be one draft or multiple drafts. The authors did that. Sudin took that action item very seriously, and I'm happy to report that the authors have had that discussion and that they mutually reached the consensus that the works, while related, can happen in parallel to one another, particularly where one draft is about to go through, or I'm going to call consensus for working group last call on the list. So that's the formal decision. I really appreciate that you guys sat down, spent the time during your day jobs to do this, particularly with the time zone changes for you guys as well. So thank you for doing that. I think as a working group, that makes sense. If that doesn't make sense to anybody in the room, please let me know. But basically, they're covering two different pieces where, as a tester, if I was going to test this, I would ultimately use both RFCs or drafts when they're in the meantime. It's just one's ahead of the other, and we don't see a reason to slow one down for the other. So that's the decision we're making, or I guess I'm going to call on the list and give you guys a chance to jump up and down if we need to. Thank you.
Thank you both. Thank you both, Sudin and Jim Utaro, who did a lot of the email discussions and set up the sort of agreed to the time. We did this at 7 a.m., but it was a really good discussion. Thanks again. All right, so our next topic is the multiple level search, and that's going to be presented by Maciek, I'm sure. And so Maciek, we heard you very clearly before. Let's make sure we can still do that. And I don't see Maciek.
I think he's coming back on here.
Oh, here he comes. Okay, good.
Okay, does it work now?
Yes, we got you now.
Okay, sorry, I got thrown out from the room. It couldn't reconnect. So I know that the connection, I'm presenting from Paris. So if at any point my audio is not coming through, I know Lorenzo from Miteco is already monitoring it, but if it's choppy, just let me know. I will slow down and disable the video. So this is about the MLR search and multiple loss ratio search. Ratko and myself, Maciek and Konstantinovich, are the authors. Next slide, please. Okay, we presented the draft on the last meeting in Prague. Here are the main changes from version 01 to 02. I think the main ones relate to the MLR search applicability and usability, and I'm going to cover some of these on the following slides. We also greatly updated the terminology section, just in case there are terms that we're using with a slightly different meaning. And we have also updated as references to the FDIO-assisted implementation. And we also added the security considerations boilerplate. Next slide, please. So MLR search is about discovering a performance, a packet throughput rates in a single search. But instead of looking and searching for a single rate, its aim is to find multiple rates, and they are distinguished with the configured packet loss ratio. And we're using it predominantly today from the implementation perspective, and the code that is running in FDIO assisted, and it's also available as a PyPy library to find two rates: the non-drop rate, which is a zero packet loss as per RFC 2544, and the other rate is a partial drop rate, where PLR, the packet loss ratio, is higher than zero, so it's a non-zero. And we're using it really for NAV benchmarking to see how close the two are to each other, for black box SUT and DUT evaluation purposes. If they are close to each other, this means that the jitter plays a very low role in packet loss. If they're quite far apart, that means that jitter related to how the software is executed and how the packets are being drained from the queues and processed, plays a much bigger role. So instead of running separate binary searches for NDR and PDR, you run a single search, or one runs a single search. And next slide. So why is this useful and applicable? Well, it reduces the amount of searches you do, or one does, and the aim is also to reduce the overall execution time required to find those rates. We then propose another way to reduce the execution time further by using shorter trial durations to start with for intermediate steps, and using the finally specified final duration just for the final measurements. And from that perspective, we believe the MLR search is compatible with RFC 2544 in the context of zero packet loss rate that is found. Next slide. So in terms of sample implementations, this is the same slide we shared last time. That's where the code lives. Current code lives in the Linux Foundation networking FDIO assisted project. There is also a PyPy package as listed, and it is being tried also by the NAV bench, the OPNAV, also Linux Foundation networking OPNAV project or sub-project, for exactly the purpose, finding the NDR and PDR rates. Final slide. So we have received reviews from Alec Hovan, who is a lead on NAV bench from OPNAV, and they are tracked in Garrett, so they are in the public, but not on the BMWG list. And we would like to welcome reviews from the benchmarking working group, and similar to what Radko was saying, we would like to make the draft adopted by BMWG and make it a BMWG workgroup draft versus the current named draft. We'd like to understand the exact steps required for this work to become a working group work. Thank you.
Thank you, Maciek. So any questions or comments on the draft? Who's read the draft that's here? Oh, several hands. Okay. So any questions on updates, things like that? One thing I wanted to talk about, Maciek, is this Garrett where you're tracking the changes.
Mm-hmm.
I guess I kind of forgot about that from your last presentation, so I sent comments to the list. But I think we've got to keep, every working group is trying to strike a balance between the, developer tools and the mailing list of old. We're kind of stuck old, so for now. But look, that's something that we can sort of begin to mix here a bit. Maybe we can. First off, I didn't get any mail from Garrett to say that that you'd addressed any comments there or anything like that. I'm not sure whether I've got to do something to get my credentials in the CSIT. Maybe this is part of the CSIT, Garrett. Is that where you're dealing with this in the I don't know, in the repo space there? I don't have the link in front of me.
It's what is required is LF credentials, so Linux Foundation.
Okay.
That's it.
All right. So my Linux Foundation user ID is ACM. You should be able to add me there, and that'll get me to an address. Get my attention.
So no adding is required. It's just the link. So we did not see your comments. I sent an update with a Garrett link to the list. I think after the Prague IETF and also once we get Alec comments before we published the updated version. But I think I agree with your comments in the sort of stuck between the old and the new. I think it should be a responsibility of the authors to keep connecting the two platforms or whatever is being used. So I think realizing it now, because I work on Garrett all the time, for me it comes naturally as that's where we operate. But Garrett or GitHub. But it probably it should be a good practice to relay comments, including the interactive comments between the two, and mailing lists is the platform for that. So I'll take that comment, and from now on, any Garrett comment exchange, we will rely onto the list.
Yeah. I sent the comments last Monday. If you, I thought I heard you say that you hadn't seen them.
That's probably because I've been traveling.
Oh, okay.
all last week and this week. So I will search for them.
Very good. They're on the list, and the date you want is the 15th. Good. Okay.
And I can see them now.
All right. Great.
Okay. Perfect.
Great. Okay. So can we get some volunteer reviewers for this draft? Yes. Come to the mic and say your name. That'll help.
Lee, H3ETRI. I will leave you and then send the email.
Okay. Yeah, even add it in the Etherpad if you can. That'll be great. Thank you. So we've got one volunteer reviewer for you, Maciek.
Excellent.
Good. Thanks. And I'll continue going through it as well. Good. Thanks very much.
Okay. All right.
All right. Thanks for your presentation.
Any more questions?
Pardon?
Okay. Thank you.
Yeah.
That's fine. Thank you.
So we'll see you again later. Try not to let the meeting kick you out.
I will do my best. Thank you.
Okay. So our next topic is the considerations for benchmarking network performance in containerized infrastructures. And welcome to your first BMWG presentation here.
Thank you.
Wait a minute. It's Yunsik Yang, right?
Yeah.
Yeah, very good. Welcome. Try to stand on the X. Yeah, there we go.
Okay. Hello, everybody. I'm Hyunjin Yang from Sungshin University in South Korea. Today, I just want to talk about updating our draft consideration for benchmarking network performance in the containerized infrastructures.
You got 10 minutes, okay?
10, okay. So we submitted this draft last IETF, and then the many people reviewed our draft. Thank you, and then thank you, special thank you for all of the name on the list. So we couldn't apply all of the comment to the current draft, but we tried to adjust the information your review to our new draft. So actually, last time when you think about this draft, we thought that in this draft we just provide some factor which relate to the networking performance in the containerized infrastructure. But so we just restop so many factors on the additional consideration part and the testing. But I think we need provide more detailed thing in this draft. So we added the 3 chapters. The one is the container networking classification and resource consideration, and the benchmarking scenario for the containerized infrastructure. So among these chapters, so we categorize the container networking technology, and then we also try to describe the different resource utilization support between VM-based and the containerized infrastructure. And we also drawing the more figure to clearly figure out what is the difference between the VM and the container. And then we also added a new test scenario for the container infrastructure too. So the first update part is the container networking classification. So in this chapter, we just classified the container networking with the 3 network model, the kernel space and user space. And then in the user space, we also classified the device pass-through and the vSwitch model. And then we also mapped current networking, containerized networking technology to this classification. So we added a 10 reference with that model. So yeah, and then in the resource consideration part, we just restop the 3 things for the container infrastructure. So when you think about this factor, we just think about how what factor should impact the containerized infrastructure. So what is the difference between the VM and the container infrastructure? So we just figure out 3, but we will add more the next time. But the first one is a huge page. Actually, in the VM we can use the huge page, but basically we should given the resource at least the 1 GB for the huge pages. But in the container infrastructure, we can adjust more granularly. So I think we thought that maybe it will impact the container networking performance. And Duma, Duma also we considered for the resource consideration. Actually, Duma is a non-deterministic, and when you instate of the CVNF, the maybe resource is non-deterministic, and the Duma also non-agnostic. So maybe we cannot figure out the exact the performance relationship between Duma and the networking, but we will figure out, and then we describe about it later. And the RxTX multi-queue also actually when you test the networking performance in the VM in prod, RxTX multi-queue, so we considered, but in the container now maybe is not supported, but maybe it also one of the factor to affect the container networking performance. And in the benchmarking scenario for the container infrastructure, so basically according to the HTST 009 document, there are 2 scenarios. The one is the container to container, and the the another one is pod to pod. But in this draft, we consider the more two scenario. One is the BMP, another one is the VMP, because when we implemented the container infrastructure in the real environment, maybe we can deploy the pod on the VM. So we also consider that scenario. So in this draft, in the current draft, we added 2 additional test scenario, and then we also draw the figure, and yeah. And then the last time when you had a meeting, in the last meeting, so many people also comment about our draft, and then yeah, one of the comment is we should consider the operational consideration. So maybe we couldn't add the concrete information about the operational consideration, but when you think about the real service in the containerized infrastructure, maybe just we think about the only one VNF, which is based on this, made by this container, is not enough. So like this draft, the service density draft, we also consider how we measure the performance in the containerized infrastructure. So we also consider that part too. And then the next step, maybe we will update about our draft again because we have some typo, so we will update soon. And then any feedback welcome. And then we also try to add the more current new technology added into this draft. And then we also think about the hackathon in the IETF because we just classify the networking problem, and then a networking model, and then we think about just vectors, but we also proved that concept, and we just want to discuss with the BM working groups members. So we don't have the specific plan about it, but if you have interest in the hackathon, please ask me and ask to other members. Thank you.
Thank you. Stay there, I get a comment for you. I guess I'll just do it here. So Al Morton, as a participant, I saw in your slides that you're dealing with a NUMA agnostic situation here for deployment, and that has a big impact on performance.
Yeah.
I was just going to refer you to the testing we did, not in the container world, but in the hypervisor VM world, as part of OPNFV.
Yes.
The VSPerf project, and all of that work has been adopted in the latest version of the ETSI NFV TST009 document, which I saw in your references.
Yeah.
So there's a new version of that coming out in June. So if you look way in the back, I think it's section or clause 12.4, you'll see some procedures for testing in that area. And then you'll see some sample results on a wiki page and additional discussion in the appendices about that kind of testing. So I encourage you to take a look at that and maybe reference some of it and examine how that works in the container world. I'd really love to see that as well.
Okay, thank you.
Any other comments, folks? Questions? Anybody read the draft? Yes, one gentleman in the back there. Okay. And us.
And
Is it somebody on Teco?
Yeah, we can.
yes, can you hear me? It's Maciek?
Yeah.
Okay. Yeah, so I did not manage to read the latest 01, but I did review the 00, and it was very promising work. Based on the presentation right now, I think looks like the good progress has been made, but I just wanted to volunteer to reviewing 01, as it seems that there may be some relation to the other draft that we have in the working group, which is the NF density draft. But this draft is approaching the problem from the more technology use perspective, where in the other work we're looking at more of the sort of abstracted way, as I will present a bit later. But I think the two pieces of work are related, and they are addressing a very important problem space. That's all. Thanks.
Okay.
Thank you, sir.
Thanks, Masia. Okay,
Thank you.
thank you.
Thank you.
Okay, so our next presentation comes from Rafael Rosa, who is remote, and Rafael is going to tell us about the methodology for VNF benchmarking automation. And Rafael, are you able to be heard?
Can you hear me?
Yes, we can. Very good.
Thanks. So I'm just following the updates from the past version. We had some comments in the meeting that Manuel presented in Prague. So
Right.
basically, I'm going to address some of these comments and how the draft is updated based on our current last prototypes and our test comparisons. So,
Very good. Try to make it in 10 minutes here, Rafael. Thank you.
okay, next slide, please. So the draft was mainly updated because we needed to have initially some clear considerations regarding these benchmarking procedures that are defined in section 4.2. Basically, they define the generic manners and considerations for benchmarking procedures in an automated way that we plan to address in the draft. We also saw that we needed more comparison factors in our VNF benchmarking descriptor definition, that we saw that based on our experiments, it was not yet fully functional. So we also needed that in the young model that we are developing to reflect those changes. And also we wanted to put all the reference implementations and the comparison tests available. They were not previously referred. Next slide, please. So the issues we are trying to address mainly in the draft was actually to refine the terminology to focus only on what is being addressed in the draft. So we removed mostly the NFV generic terminology from the draft. We also defined that the generic benchmarking procedures would reflect the overall methodology that we are addressing in the main section of the draft. And especially when we are running the tests with our open source reference implementations, we had issues ourselves in the members of the draft, that we saw divergences in the probers and listeners. How we are executing the parameters of the test. So we would have better definitions of these test parameters, so we can have a better comparison tests with the reference implementations. Next slide, please. So based on that, the major technical changes that we had were that we filtered this only important concepts in terminology. We defined it in this section 4.2, the generic phase that we think that addresses a generic benchmarking procedures. Since the deployment of the scenario, the configuration of the whole benchmarking deployment scenario, the execution of the test itself, and how the tests are reported, and the main important updates in this draft was the refined VNF benchmarking descriptor structure in section 6.1, where we defined the whole fields and definitions of what is inside each one of these sections in the VNF-BD definition, the headers, the information of the target, how the experiments are defined, especially the environment settings, like how the components are going to be orchestrated or not in a deployment scenario. The scenario itself, like the topology for the test, how it's been defined, this structure. Here we are thinking about referring to the the actual existing Tosca or Young reference that we're still trying to see if it's feasible or not for this VNF-BD model, or make it more generic as possible. And we also defined the proceedings that mainly define how the VNF or the SUT in this case is benchmarking, and the whole tools and the parameters for these tools to operate and generate the test results. Based on that, we updated the VNF-BD Yang model, and we pushed the GIM updated reference open source repository to the draft as well. Next slide, please. So what we still have to do, and we need further discussion, we have still the section that we are now addressing is the VNF performance profile structure. This concerns mainly the report of the results of the VNF benchmarking descriptor execution. So in this case, we are mostly concerned about the generic representation, but useful enough for an orchestration solution to have it as a source of data for analytics platforms. We are also mainly working parallel with the writing of the draft and the comparison tests with our open source reference implementations. So we are mostly concerned about in the next version fully demonstrated the importance of the draft in the whole definition of the VNF benchmarking descriptor and the VNF performance profile, how they can be compared with each other in different instances, and especially in different our reference implementations. So this is all open source as well. And then in this case, we are also planning to showcase the validity and the utility of the young models that we are developing for the VNF benchmarking descriptor and the performance profile. We still have a lot of work in the BMWG that we see that's related, especially the last presentation, for example. We are addressing those, and we plan to take considerations for each one of these ongoing drafts as well. So next slide, please. So yes, that's all, and we invite you guys to review and then share your comments about the draft. Thank you.
Very good. Thanks, Raphael. So any comments on the topics that Raphael covered very efficiently there? There's obviously a lot of work behind this, and I was interested to try to get a side meeting going where we could see a demonstration of everything we have seen contributed by Raphael and his team, but that doesn't work out if you're remote, Raphael. So
Yes.
yeah, the side meetings are all sort of not covered, and but that's okay. Well, so we'll try to get that done at a future meeting or some other opportunity where we can see the demo, maybe an interim meeting, something like that. Okay.
Yes.
So any volunteers to review the draft and or look into the code repo? Yes, one in the back there. Okay. Please come up to the mic and give us your name.
Luis Contreras from Telefónica. So I volunteer
Oh,
to review
Luis.
the draft.
Okay, good. Good to meet you, Luis. Thank you. Okay, so we've got a volunteer for the review. And anything else? I'm glad you recognized the overlap with some of the other efforts, Raphael, especially the Yang model for the tester control that Vladimir has proposed. He's got some text on that, and that's something to look into too, as a kind of like a cross review for sure. I see.
Yes.
I see Vladimir nodding. So so that's
Our idea is just to get closer and closer to the ongoing drafts as well. So we have more ways to show the let's say how our draft can be useful for the other implementations and vice versa.
Sure. And don't forget some of the other industry references too. The the work going on in Etsy and OPNV is they've got benchmarking tools there and specs that are quite relevant to the work you're attempting.
Sure.
Tim Carlin, Munich. Curious enough, I'm going to go take a look at the code and let you know if see anything interesting there. Any problems?
Excellent, thanks. So it's Tim Carlin, sorry, Tim. It's Tim Carlin from.
Put it in Etherpad.
Oh yeah, great, thanks. Tim Carlin from the UNH Interoperability Labs is going to go dig into your repo. So be prepared. Okay.
Perfect. Thank
Try to
you.
get some stuff running. You're going to get some Garrett changes out of that, I'll bet.
Thank you.
Okay, thank you. So next up, we're going to be moving back to Maciek for the NFV service density benchmarking discussion.
Okay, I should be back.
Yes, we can hear you. Good. Sarah's quickly and efficiently bringing up the slides here today.
Excellent. So I will try to stick to the best practice of keeping within 10 minutes. And
yeah.
All right. So hello again. I'm Maciej Konstantinowicz. We'll be presenting the work we've been doing with Peter Mikus, who is also one of the remote participants on the NFV service density. Presented the first presentation of this work was in Prague. Next slide. Here we also received comments on LFN FDA-assisted Garrett, which we addressed, and the major updates are related to the adding specific NFV service data plane benchmarking metrics, which I will cover on one of the next slides, and also on the request from Alec from NFV Bench. I added the references. We added the references and also the placeholder for the results, as he's applying the methodology to the NFV Bench tests, including the plug fests that I think he is intending to running NFV Bench within the context of OP NFV, and also added the security consideration section. The target of the draft is ability to benchmark network applications independently if they are running on bare metal, VMs, or containers, and trying to capture and also abstract the way that the network applications, which we're referring to them here as network functions or NFV services, are actually deployed. Next slide. The three main the main challenge we are aiming to address with the draft is measuring a performance of the single network function application or network application on a server running solo is fairly straightforward. It gets harder if you have many of them, or they are in the presence of other applications, and basically trying to address the noisy neighbor problem. So in the context of when running only network applications, but many of them, and them being arranged in some sort of virtual topology, in service chains or service topologies, the presence of virtual topologies and also complicates the problem. So the idea is to come up with a fairly universal or generic way to benchmark those NFV services as defined. Next slide. So what are the main factors impacting network application performance? The direct factors are clearly the software code that distributes the processing packets and its configuration. The way that this application built of this code are arranged in virtual topologies, and the external stimuli that drives the setup. But there are also two other indirect factors, and that's the virtualization technologies used to create those virtual topologies, and like VirtIO or vHostNet, vHost user, or MEMIP in container space, or virtual Ethernet. And then also the way that the network application is connected to the physical network, which we are calling here a host networking. Next slide. So the proposed solution, the solution proposed in the draft, and it's pretty much the same slide as I presented last time. So a very quick recap is to separate the three aspects of the NLP design: the service packet processing part, so the network application layer itself, and the shared virtualization infrastructure, and then the shared host networking infrastructure. And from the resource allocation perspective, focus addressing the noisy neighbor problem is, for starters, to focus on allocating the resources as per current best practice. So that's processor core pinning, affinity, and limiting the Linux jitter. Or operating system jitter. I should add that bullet point. It's covered in the draft. And going forward, and that's what's covered in the draft. And going forward, look at what degree we can also manage the LLC resources, the last level cache resources. And this part is a subject for future work and is currently not covered. Next slide. So the way we define the service, we abstract it across three layers, topology at the top. This is how the network applications, network functions are connected or interconnected. Through the host data plane or directly, a configuration, so how they are configured, and the final one is what is the actual packet flow, the packet path through the service definition or service chain, and so that's the defined service abstractions so far. And the next slide shows the defined scenarios that are basically applying the service abstraction to the scenario. So within the draft, we defined three scenarios. One of them based on the network applications running in VMs. So we refer to them as VNFs and VNF service chain through the virtual switch, as shown. And with the other two are based on containers, which we refer to as container network functions. So this is the network application running container. And we have a snake forwarding, so service chain with snake forwarding, and the last one is we refer to as CNF service pipeline and pipeline forwarding with horizontal interfaces. Next slide. In terms of the benchmarking metrics, so this is the content we added to the version 01. We want to measure packet throughput in packets per second, and then calculate the bandwidth throughput based on the packet size and such in bits per second. And the applicable types of throughput rates that we have listed include the NDR, so zero packet loss, PDR, so partial packet loss, and MRR, which stands for maximum receive rate. And we added the definitions of what that exactly is in the draft. So this is the maximum that you're getting through the system regardless of packet loss. And then we also have latency that is measured at different packet loads. And we sort of provided the high-level guidance of light, medium, and heavy load without the actual strict definitions. And the latency being measured in both forward and reverse direction. Next slide. So next is a set of sample measurements. Due to time, this is basically the way we defined various core resource allocations to the data plane workers. I will skip the slide. Next slide, please. And this is really to illustrate the resource allocation to the two set of graphs the next two slides are showing, where the network applications are running either on one physical core or they're running on a half physical core, basically running hyperthreading and using only a single logical thread, where we can get higher density of those network applications. Next slide. So these are the tests that we run in FDIO Assisted, and also there is a CNF testbed project within the CNCF where they run a similar test, and there is a reference later on to that project. So this is basically running multiple of either VNF service chains, CNF service chains, or CNF service pipelines. And you've got the versions of software used here. In this case, it's VPP 1904, which is what we run in FDIO system. Next slide. So these are the graphs, and the main really message here is that, the top level is that there is a comparison between the VNF service chains, CNF service chains, and CNF service pipelines, where the device under test, so the device that's actually under load and oversubscribed, is a virtual switch. And it clearly shows that the pipeline is better because the virtual switch is processing packets only at the entrance and exit to the service instance, whereas for the other two, it goes and takes part into processing the packets in between the VNFs or CNFs. And the CNF is slightly better, faster, due to the containerized virtual infrastructure for packet processing for the middle case. Next slide.
So that's 10 minutes, Maciek. If you can wrap it up here, please.
Yeah, that's the last slide. This slide just shows a very similar metrics, with a higher density of network functions. Again, the results are specific to the application tested. In this case, VPP. Next slide. So. Similar to previous comments that I made on the MLR search, I welcome more reviews from BMWG. We have received comments from Alec from OP&V and VBench project, but that's pretty much about it. We had discussion at the Prague IETF, but we'll welcome more comments in terms of applicability of this work and specific steps to make this BMWG draft from the current name draft.
Thank you, Maciek. So there's a lot of obvious reviewers here, the folks that mentioned some overlap and that you've observed some overlap with this work. So I hope some of those folks will volunteer to be reviewers here. One technical comment before we do that, though. I noticed your data plane metrics for latency and so forth. I think there's already good metrics in test 009 that cover most of that space. They're slightly different names, but we've got good metric definitions there, and I would hate to see that sort of get renamed in this work. We can do the cross-referencing. Look to BMWG terminology first, and then the ETSI NFV terminology next, before we go inventing something new. And I know stuff has been used in practice for a long time, but let's try to reuse the standard definitions where we can.
Of course.
Thanks.
Yeah, we'll take this feedback. So we'll cross-reference to TST 09 in the next version. Thank you, Al.
Good. So now I'm going to ask for volunteer reviewers here so we can move this work along.
Raphael on the Jabber room is signing up.
Okay, that's good. So Raphael, the automation system has signed up to review your draft there, Maciek. That's good.
Excellent. Thanks very much, Raphael.
Thanks. And
okay, thank you.
Okay. All right. Thanks very much. So now we've got a couple of drafts on. We're going back to the EVPN topic. We've got a couple of drafts from Sudin, and the first one's on EVPN multicasting. Let's see. Let's go a total of 15 for both. How about that? And I'll
both sides.
For both sets of slides.
Yeah, I'll try.
Okay. 7.5 each.
Right.
Start.
Yeah, go ahead.
You have that
the
clicker.
Yeah, here we go.
Thank you. Yeah, good morning, everyone. The benchmarking draft. This is based on the parent, the EVPN RFC 7432 and the recent draft, which is adopted by the IETF Best Working Group, EVPN IGMB MLD proxy, which is widely deployed in data center and the MPLS service provider network. So we are defining certain parameters to benchmark, because currently there is no way we can benchmark these services, which is already implemented. So we are defining certain parameters to measure this EVPN IGMB proxy draft, which is currently adopted by the IETF in the Best Working Group. So this is a topology in our lab. So we have the leaf. We have a leaf which is a multi-home, and we have two DUTs. One DUT is a single home, and one DUT which is connected to a multi-home EVPN multi-home active scenario. And we have spines, and the RT is a traffic generator which is connected, which is emulating the host as well as the source for the IGMB as well as the multicast traffic. So these are the parameters we are defining to benchmark this service. So we are defining the IGMB join latency. So how fast, which is IGMB, it will join the DUT once IGMB report. The membership report comes to the DUT and it sends the type 6 routes and able to get the traffic. And then the IGMB leave. There are two types of, one, you send IGMB leave, or it is a timeout if the host is not responding to that. So how fast it is gonna leave. It has to stop the traffic unnecessary flooding to the system. So these are the two, clearing the state as well as the leave latency as well as the IGMB in the leave as well as the timeout. Then that is for the single homing DUT. In multi-homing, we have which is different from the single homing devices, which is clearly defined in the IGMB draft, wherein you have active scenarios. They have a couple of routes which is defined to join sync as well as the leave sync. So the test environment is different from the single homing devices. So so that is why we have testing for the IGMB join as well as the leave timeout, as well as when you get a leave message, IGMB leave. So how fast it stops and it's not flooding to that, and how fast it is syncing the routes between the multi-homing devices, so that that traffic should flow into the system, so that it how fast it goes, so that you don't feel the there is a ghosting of the channel, or there is a picture freeze like that. So how fast? So based on this parameter, we benchmark the boxes or the devices. Then we have certain negative scenarios which we defined during multi-homing. If one of the router fails, if the link goes down, so how fast is going to sync and start forwarding the traffic to the C or the host which is connected. And we have a core failure. If the core failure which happens, how fast the traffic which is going to redirect to the other forwarder which is working in the multi-homing. And the traffic starts flow once the core is failed, so it has to immediately detect the failure as well as switch the traffic to the other multi-homing router. So we have a scale test wherein we emulate a lot of host as host in the network, and we send a lot of IGMB membership report. And so how fast which is gonna the box is gonna handle this kind of surge in the traffic, as well as it starts forwarding it during scale convergence testing. Then it's a traditional high availability test run for a period of 24 hours, and see we are not getting any core or any memory leaks. And the high availability is where there is a routing engine failure. So how fast it's gonna take the load. and we are defining the soak, which is running over a period of time for 24 hours. So the expectation is the system should perform. There should not be any memory leak, and there should not be any core generated, and the system should work as expected. So these are the parameters we are defining for benchmarking this EVPN IGMB proxy services. So any questions on this? So this is just an expansion of what the parameters we already mentioned, like how the learning rate, because that is very important, because different boxes, the performances are different. So because in a data center or in a service provider, you have a lot of multicast channels, services which is going. So the learning rate is one of the important parameter to define a box, like how fast it is going to learn the membership report and sends the route and just joins that then joins the tree and sends the traffic to the segment, as well as the leave is also, because that is one of the important factor wherein it should not flood the unnecessary flood to the segment, and it should not and if it is it's not timeout, it is going to flood the system and it will be a wasteful of bandwidth. So the timeout is IGMB timeout is one of the parameters wherein we see how the box processes a large number of messages. The IGMB messages once it is not refreshing it. So how fast it is going to time out and stop that the multicast traffic to the segment. So the system, it should not. Even if it is timeout, it should not send the traffic to the system, and it will be a wastage of bandwidth. So the leave latency is wherein when it gets a IGMB, so IGMB report, so it's for leave messages, and it should stop at a very large rate. It should stop immediately, because there will be box performance based on different boxes. There will be a sometimes there is a lag in that. It won't process immediately. There is a time period wherein it's again starts sending to that local segment. So we measure that how fast the box is gonna, once it get the leave messages, how fast the box is gonna behave this. So this is a typical scenario wherein this routes, because the EVPN new type of routes which is defined in the draft, because type 6, 7, and 8. The 6 route is wherein it's a IGMB SMAT, and 7 and 8 is a joint sync in multi-homing as well as the leave sync, because the multi-homing is very important. Like if one of the non-DF, one of the non-DF gets the join messages, then it has to inform the DF, and it has to send the type 6 routes. So how fast is it, because it is the interaction between the multiple routers in the EVPN multi-homing scenario. This is where one important things wherein we measure it, because that is very important in the data center as well as in the service provider scenarios.
That's about 7 minutes. So.
Okay. Yeah, this is an expansion which I already mentioned. Like it's we are measuring the failures. Like the failure rate is important, so that to how fast it is going to mitigate these failures. So we are doing that either the designated forward down. Doing local link failure, core failures, then the routing engine. Suppose if the routing engine process itself fails, and sometimes the DF, the designated forwarder itself fails. So these are all the type of failure. We do it on the system and see how fast it is recovering it, and mitigate the failures. And the scale is where we send large number of, we first determine these are the number of VLANs where we'll be using it. And this is the number of groups, and based on a determined scale of N, how the system is gonna behave on that. There are a couple of scale convergence tests. First is a normal scenario wherein how fast it is gonna how fast it is going to set the traffic, and during any failure, how fast it is going to recover it at a scaled environment. So every box, and it depends on the CPU and the memory, it behaves differently. So this is where we define a parameter and measure the system performance. That's it. Thank you. So how many minutes?
Let's see. About 5 minutes left, a little less than 5 minutes for the other one.
Oh,
We'll
okay.
cover the other one and then take questions, Sudhin?
You have any questions on this?
Seems not.
Yeah. So this is EVP and VPWS. This is defined in RFC 8214, which is recently converted into RFC. It was running as IETF draft recently. I think around 6 months back. It moved 6-7 months back. It moved into RFC. So now, in traditional, because in VPWS services is there for a pretty long time in service provider. The problem with VPWS service is a point-to-point, but you don't have a multi-homing features in VPWS. So the EVP and VPWS services, one of the advantages, like we can have active forwarding to the system point. Even though it is a point-to-point services, you can have more than one router, load balancing the traffic to the same CE. So that, and you can work in two dual modes, like single active as well as the active. Either you can work as active backup. You don't need to lose a link, so you can work as primary backup, or it is active. You can utilize both the links. So this is our test scenario wherein the DUT is used as one of the multi-homing Ps, and which is connected to a CE, and we have a router tester which is connected to the CE as well as to the single home P. So these are the parameters to measure how to measure these services. Like these services are widely deployed, so how do you gonna rate the system? So we are defining certain parameters on based on our exhaustive testing. So, and we found out, okay, hey, these are the list of parameters based on this particular device under test, or the this particular routers, and depends on the memory, depends on CPU, the performance will be different. So these are the parameters we defined, how well the box is gonna perform for a local link failure, so that immediately it switch to the other multi-homing device and start forwarding it. Then the core failures.
So Sudhin, you're almost out of time, and since these parameters are well understood and defined in your draft, I suggest you skip to the stuff you want to focus.
Okay, I think it's.
I didn't mean to think that.
No,
That's why I made it a crisp. So that's why I didn't expand it. So I made it a crisp point in that. So I think I'm done. Like next step, it's like comments and support. So either you can send a mailing list, or if you have any questions, please feel free to ask the questions.
Sudhin, here's my suggestion. Why don't you circulate this draft, and on the, I guess, the BES mailing list is try to get some EVPN expertise to review it there, and to place their comments on our list if they're willing, or at least exchange some commentary here. Has anybody read either of these two drafts? 2 people. Okay. That's good.
So I agree.
I'll do.
We've talked a lot about having this reviewed outside of this working group. So putting it on the working group list is a good start. If you don't get the traction that you're looking for, make sure you're signing up. Potentially ask the chairs if you can get airtime and the next meeting, so you can trump that support. But we're going to need other folks to read this, because
sure. I'll circulate in the BES. I'm also part of the BES working group.
Okay.
So because I'm also subscribing to that, because I'm also active participant in that, and definitely I'll talk to them.
Okay.
Perhaps the first step is like I'll first send the mailing list. As you said, like if you're if it depends on the traction, if support is not, I'll check with that if get some airtime,
Yeah, just keep us and the list in the loop, so that we're
definitely
seamless.
definitely.
Okay.
Yep.
Thank you.
Thank you.
Okay.
Thanks, Al.
Yeah, don't turn that off or anything. The next guy's going to come right up.
Hello.
Yes, here. Luis, come on up. Okay. So Luis Contreras, welcome to the working group.
Thank you.
We're going to have your slides up here in a minute.
Oh, sorry.
Okay.
That's okay. No problem, Sarah. You're doing a lot there. 5G, I'm not on the mic. The topic is 5G transport network benchmarking. There's a lot of open space here that Luis is going to try to cover in just 5 minutes.
Right.
Yeah.
Okay. So, okay. So, yeah, the idea is of this draft is basically to start digging on the 5G on the implications of 5G in the transport networks. So yeah, so, thank you. Thank you. So basically, the motivation is that now several operators across the world, Americas, Asia, Europe, are starting to deploy 5G access. So 5G is for sure impacting multiple technological areas, the radio for sure, the mobile packet core, but also the transport network. So the idea of the motivation of this draft is to start pushing on having directions, guidelines for benchmarking the transport networks in such a way that could assist us, the operators, in the deployment of this and in the support of the services that are expected to be offered to the customers. So there in the graph, you can see the different kind of impacts. I think this is more or less well known, so I will pass to the next slide. So the scope of the draft will be basically to overview available solutions. So for sure there will be available solutions, and even in the benchmarking working group and also outside. So start overviewing what is available there, identify the gaps that could require further work. So the idea of this draft will be to provide also directions for future work, future technologies and so. And finally, to provide guidelines on the 5G transport network benchmarking and also, basically defining these next steps. So the subjects of benchmarking analysis that we have identified so far, and probably this could be somehow refined in next versions, could be basically data plane. In the data plane, we could identify two different kind of impacts, hardware capabilities or either encapsulations. Examples of this would be TSN, for instance, IEEE TSN, but basically there is a different handling of Ethernet frames and so with impact on the hardware. And regarding encapsulations, clear case could be semi routing version 6. Also impacting subject of analysis could be the control plane. And here we have a clear example with the RFC 8456 for SDN. Probably this could be enough, maybe not. So it's something to analyze. Regarding the management plane, an example of a potential topic could be the network's life cycle, focus on the transport capabilities, basically. And regarding architecture, another topic that is being developed in IETF could be the deterministic networking, so all the architectures about the net. So the proposed next steps is basically for today to collect interest from the working group, if this is interesting for the working group to progress on this direction or not. And if so basically start identifying the requirements and characteristics that 5G imposes in each of the subjects of interest that we have seen before, and preparing some progress for the draft for the next IRM meeting. So the idea now would be to now or in the mailing list to see if this is of interest for all of us, and if so, start defining the next the evolution of the draft, basically. So thank you very much.
Very good. Thanks, Luis, and thanks for making that timely. Please come on up.
Yeah, this is Will from Huawei. I briefly read this draft, and I think, for example, first of all, 5G service is promoting here. However, 5G service is a kind of large topic. I see that you mentioned all the three kind of use cases and several categories of benchmarks. However, I think that will make a lot of efforts to fulfill this work. So I would suggest that we limit the scope into, for example, I don't know whether you want to do for example, the 5G slicing or 5G data plane services, something like that. So that's my point.
So Will, that's your input on priorities. You'd rather see that done first, and then work on something else after we've learned about that in some detail. I think that's good feedback. Thank you.
Just to mention, in my view, basically the idea of this draft probably would be to point out. I mean, what I expect is not to cover everything in just one single document, so having a different number of documents. So these are probably could provide an overview with the development of specific areas in other specific documents for that. So maybe this could be a way of proceeding.
Yeah.
So comment from Sarah as a participant. We're not typically the experts. Every single person in BMWG isn't the expert on wireless networks, cellular networks, right? So the first question that I had when I saw this was, well, why can't you characterize these same things the way you did a 4G network? And I'm not proposing you answer that now. I realize that that's absolutely a little bit of a longer answer, but it'd be nice if you would consider, I can ask that on the list and you can answer on the list, even if we had a post to point folks back to. Because it's questionable, should this happen here? Should this happen elsewhere? I really hope it happens here. I think it's a good thing to do, but I would actually like to know the answer to that.
Oh, okay.
On list. Sorry, I didn't mean to.
Okay.
Yeah. Thank you, sir.
Okay. Thanks, Luis. Welcome to the group. Okay. So
All right. You have 4 minutes and X seconds, and I'm going to hold you to it.
Okay.
All right, sir. Oh, slides.
Okay, so this is the draft on individual draft from me and Jim Utaro, who did stay through the whole meeting. Thanks, Jim. And it's on benchmarks and methods for multi-home DVPN. Next slide, please.
You have the clicker right there, sir.
Oh, I do. Yeah. Okay. All right. So, Sudin, thanks very much for your comments. We had a detailed reply on the list. This is a summary of changes in the O2 version that follows. So we got the that's for the last guy.
Yes.
Yeah. Oh, I'm done. Al Morton, participant. Okay, so these are some of the things that we've added as clarifications. It basically comes down to a recognition that we have a lot of material that we've drawn from other benchmarking RFCs into this draft, and we skipped over it in the early versions. Now we're trying to make it very clear. So we're going to be very careful about the connectivity between the CEs and the PE, stuff like that. The diagrams need to show that pretty well. Flows and five tuples and so forth. There's going to be full mesh testing in some way. And the tester requirements from RFC 2889, you're going to see that all over the place here. So that's part of the updates. This is figure 2 that we have clarified there to be sure that we're showing how the CE on the right-hand side, CE2, is connected to the test device. We kind of ran out of ASCII space there and had to move the whole thing over. No big deal, right? Okay, so then, here's an example of sort of the unicast flows and the frame formats must be specified. All this stuff is 2889 specified already, but now we've got explicit pointers to everything. So it should be much easier to move between the two documents and not repeat everything else here. So I think that's what we've accomplished basically out of the adding this new section. Basically 5.3 is a detailed procedure, which is a completely new section. And so then let's discuss or draw the solution. Sudin said if the remote PE is single homed and there must be a router tester connected to it, are you suggesting that we remove the single homed CE2? We can do that, but then we lose a simple symmetrical test case. That was my response. And so we're also kind of looking at maybe a new setup like figure 2 should include a CE which is single homed to PE1 with ESI 0. So going back to that picture, oh, there we go. So we'd have another CE up here, which is single homed. I think that's one of the pictures that Jim drew. So that's one of the things we need to sort out and try to accomplish here while we're all sitting around together. And so there was other interpretations of that. We wanted to be sure that that was really kind of what you wanted and what Jim had proposed as well. So let's the three of us sit down and make some progress on your comments this week. We'll inform the mailing list, and then we'll just move ahead. Thank you, Sadine. Thank you, Jim. Thank you, working group. Any comments here at this point? You'll. Thanks, Sudin. So Sudin says he'll update the mailing list. Thanks very much. Okay. So we've got like 1 minute left, and I think we wanted to do something in that 1 minute, didn't we? What did we want to do?
So can we make sure anybody who hasn't signed the blue sheets signs the blue sheets?
Yeah, that's right. We got 25 plus people here today.
And a not so gentle reminder that when you read other people's drafts, they'll read your drafts.
Right.
Please read drafts.
That's exactly right. Did you sign? Come on, for folks in the back who may have wandered in, please come on up and sign the list. Thank you. Here's the pen, Jim. Sorry. Yeah.
You can't invisibly sign.
Yeah, I know. Blood. We want blood. Yeah, very good. We'll arrange that side meeting this week. Good. Thank you. Thanks everybody for attending, and thank you, Warren, for your everlasting support.
Yes.
Next week I'll start getting list for the best workers. Okay. So let's see if already I'm participating. Then I'll formally send a mail to those folks.
When is best?
Best is on Tuesday afternoon.
You could consider talking to just a suggestion, student. It's just me, not a chair requirement. But you could consider reaching out to working with chairs right now to see if there's time at the end of your agenda this